Hello and welcome to your first hands-on experience with wireless sensor networks. Today we're going to wirelessly send messages over the air between sensors and actuators. We have a simple sensor, a push button, and two actuators, an LED and a buzzer. We're going to transmit the sensor data to the actuator side, which will react accordingly. That is, if we press the push button, we will like the LED to light up or the buzzer to buzz. Let's take a look at what we're going to need to complete the lab.
You will need one breadboard. If you want a more realistic scenario, two breadboards are better. Hookup wire, preferably divided in a set of 4 colors. 2 Arduinos, 2 USB A to B to power the Arduinos, one 10K ohm resistor, one push button, one buzzer, 2 breakout boards, one XB configured as a coordinator AT, one XB configured as a router AT. These two need to be able to communicate as in the last lab. One USB A to Mini B to configure the XB and a computer. We're going to start with the push button side first. Plug the push button on the breadboard. The current flows through the button diagonally, that is, from the upper left leg to the lower right leg and vice versa. Pushing the button completes the circuit. Energize the breadboard by hooking a preferably red wire from the Arduino 3.3 volts output pin to a power rail in the breadboard. Hook up a preferably blue wire from the GND pin in the Arduino to the ground rail in the breadboard. Place the coordinator AT-XB breakout board with both sides on different sections of the breadboard. The space separating the sections should pass under the XB. Use a preferably red wire to connect pin 3.3 volts of the XB to the power rail on the breadboard. Then use another color cable to hook up the XB ground pin to the ground rail in the breadboard. Grab another color cable to connect the pin transmit or digital out of the XB to digital pin 0 or RX on the Arduino. Use another color of hookup wire to connect RX digital in of the XB to digital pin 1 TX on the Arduino. Attach the button to the digital input 2 of the Arduino, making sure to connect the 10K ohm in parallel between the button and the Arduino input. Now we're going to build the circuit for the buzzer. Start by placing the router AT-XB explorer the same way we did before. As with the push button circuit, energize the breadboard by hooking up a preferably red wire from the Arduino 3.3 volts output pin to a power rail in the breadboard. Then do the same with the ground pin and the ground rail. Hook up the XB ground pin to the ground rail in the breadboard too. Connect the pin 3.3 volts of the XB to the power rail on the breadboard. Use a color hookup wire to connect the TX digital out of the XB to digital pin 0, RX on the Arduino. Use another color of hookup wire to connect pin RX digital in of the XB to digital pin 1 TX on the Arduino. Now we connect the buzzer to the Arduino by plugging the negative cable to the ground rail in the breadboard, and then the positive wire to one of the pulse width modulator pins on the Arduino. These PWM pins write an analog value of a determined frequency. That's what makes our buzzer buzz.
Now that we have our circuits ready, let's write some code that will allow us to send the data from the push button to the buzzer side and do something with it. At the moment we have configured both XB, coordinator and router as in the messaging lab. That is, they belong to the same PAN ID and have the other's source address as destination address.
Let's start with the push button Arduino. First, open the Arduino IDE and establish communication with the Arduino board by specifying the port and the board models. Every time you want to upload code to the Arduino, you must remember to disconnect any cable plugged to pin 0 or RX. Otherwise, you will receive an error. As you can see in the code, we defined the pin where we connected the push button as button. Then set button as an input pin and start the baud rate of the serial interface at 9600. At the loop function, we're going to read the pin status. If it changes to high, then a letter D is sent over the Arduino serial interface, which we connected to the XP. The last line indicates a delay of 10 milliseconds. This is a security measure preventing the serial interface from being overwhelmed with messages when the button is pushed. We're also giving a name to the pin where we connected the buzzer to. We call it bell. As with the button, at the setup function, we set the bell as an output pin and start the serial interface as a baud rate of 9600. Because we're sending a capital D every time the push button is pressed, then we want to read messages and search for that letter. First, we check if there's something in the serial interface. If so, we check if the arrived message is a capital D. If we receive a capital D, then the analog write function will ring the bell. We let the buzzer buzz for 10 milliseconds and then turn it off. Let's load the code and give it a try. Notice that when we press the button, the buzzer circuit receives a capital D, and the Arduino sends a PWM wave that makes our buzzer buzz.
If you're experiencing problems, try increasing the delay after pushing the button in the Arduino code. This delay prevents sending too many Ds while your finger is on the button. Can you send a melody to the buzzer instead of a single wave? Let us know in the comments.